Hi, during this session, we're going to go through some of the things in your data analysis assignment for project 2. Since I'm expecting that a lot of you will probably have quite a few questions about that one. I know the information on confidence intervals isn't necessarily easy, and some of the formulas get a little bit complicated. So I'm going to try and go through all of that with you. So I'm just going to use an example of a sample of M&Ms that I had. These are plain M&Ms, and we're just going to go through all the things in that data analysis assignment. So the first part of that was to choose a confidence level and a maximum margin of error that you would be using for your confidence intervals. And then the idea with that is to put that into the formula for the minimum sample size and make sure that you have a sample size that's big enough to use those parameters for your confidence intervals. So my sample size that I have is 349. And I decided to make an initial choice of using a 97% confidence level and a 3% maximum margin of error. And when it says the maximum margin of error, I want you to be sure and hear this, that the margin of error you choose here is just a maximum margin of error. When you actually calculate the margin of error later in this assignment, it is not necessarily going to come out to be exactly the number that you chose here. It should be no more than that. So for most of you, it should come out to actually be a little bit less than that number. If you're just plugging in the number you choose here as your margin of error, then that's not actually calculating the confidence interval. So that's not what you're meant to do with this. Anyway, so the idea is to take these two choices and then use the sample size formula and see what that comes out with for what the minimum sample size would be for this. Okay, so here's the formula. So I'm going to plug all these things into this formula, and there are a couple of other values that I have to put in here. So for the 97% confidence level, I'm going to use that to find my critical value, so my z of alpha over 2, which goes into the formula right here. The maximum margin of error, that's going to be the E in the formula. But one thing that's very important whenever you're talking about formulas that have to do with proportions is if you have a percentage like this, you have to change it to a decimal. So to use this in the formula, we're going to have to change it to 0.03. So that will be the E in the formula. The other thing I have to do is look up that Mars Company letter, because the P star in this formula is a prior estimate of what our proportion might be. So for this, I'm going to look at my Mars Company letter, and for the variety of M&Ms I chose, which in my case was plain M&Ms, I'm going to look in that letter and see what the biggest percentage was for any of the colors. So for me, for the plain M&Ms, the largest percentage listed in the letter was 24%. So I'm going to use that for my prior estimate. So I'm going to use, and again, I have to change this to decimal to put it into the formula. I'm going to use 0.24. Okay, so with those things, I can get all the numbers I need to put into this formula. I have the E and I have the P star. The only one I need to actually find is the critical value. So I'm going to go back to my confidence level and go through all the steps to find my critical value from that. So if my confidence level is 97%, that means my alpha is 100% minus that. So that would be 3%. And again, I want to put this in decimal form, so I'm going to make that 0.03. That means my alpha over 2, I just take this and divide it by 2, so that's going to be 0.015. To find the z-score that goes with this, since we're talking about standard normal distribution, here's my picture. I've got my normal distribution with 0 in the middle, since that's the mean. The easiest way to do this is find the cutoff value in the left tail, so that the area in the left tail is my alpha over 2. So to do this, I'm going to use the inverse norm function on my calculator. Okay, so here's my calculator. Now, because this is going way out to the left, I'm going to put in a big negative number for my lower bound. So I'm going to put in negative 10,000, or whoops. Actually, for this one, I was thinking of a different problem there, sorry. For this one, I just have to put in the area and then the mean and the standard deviation. And in this one, it already has my mean and my standard deviation as 0 and 1. So actually, all I have to do is put in 0.015 for my area. Okay, so let's see if I can get this where you can actually read it. This is what this would look like. I'd have inverse norm, 0.015, a comma, a 0, a comma, and 1. That's going to give me a negative number. For my critical value, I just take off the negative. So I'm going to take that and round it to 2 decimal places. So that means my number over here rounded to 2 decimal places is negative 2.17. I have another one on this side that would be positive 2.7. So that gives me my z alpha over 2 of 2.17. Now I'm going to use my formula over here. And just plug in all of the numbers that I have. And again, everything in this, if it was a percentage, it has to be in a decimal form. So I'm going to take my 2.17, I have to square that, and my P star was 0.24. And then I have 1 minus 0.24. My E up here was 0.03, and I have to square that as well. So I'm just going to take those things and plug them into my calculator. And I'm actually just plugging all of this in at once. I'll put this up here so you can see it. I'm doing it all in one line. And then with this, what comes out is 954.3. When you're doing minimum sample size, you always have to round up to the next biggest integer. So this would round up to 955. Okay, that is way bigger than the 349 that I actually have in my sample. I don't want to go back and buy a whole bunch more M&Ms to get it up to that amount of M&Ms. Even though I like chocolate, that seems like an awful lot of M&Ms. So I'm going to go back and change some of my design choices up here and see if I can get this down to a reasonable number that's less than the amount I actually have in my sample. Okay, so I can change either one of these things. If I lower my confidence level, that's also going to lower my minimum sample size. If I increase my maximum margin of error, that's also going to lower my sample size. So I gave you an example in the actual data analysis assignment. So I'm going to do a couple of other examples. Let's say that I just change both things. Let's say that I decide to use a 95% confidence level and a 4% maximum margin of error. Okay, so that means I have to go back and recalculate some things. I have to go back and find another z alpha over 2. And this means that I'm going to use E equals 0.04 in my formula. So for this one, my alpha is 5% or 0.05. So my alpha over 2 is 0.025. Then again, what I'm doing with this is I have my normal distribution. I want to know the cutoff value right here so that my area in the left tail of this is 0.025. So I'm going to go back to the inverse norm and put in 0.025 instead of the number I had in there before. So here's what I would have on my calculator. If I do that, it gives me negative 1.96 if I round it to 2 decimal places. So my critical value is that, just with the negative taken off. So now I have z alpha over 2 is 1.96. My E is 0.04. I'm still using 0.24 for the prior estimate. Okay, so I'm going back to this formula and I'm changing these two things. So I'm changing this to a 1.96 and I'm changing this to a 0.04. Okay, so if I do all that, I get an answer of 437.9, which I would have to round up to 438. That's still too big because my sample size was only 349. So I have to do some other kind of change. So the basic idea of this is to keep going, change your design choices until it matches what you have in your sample. And it doesn't have to be super close to it. It just has to be less than what you have for your sample size. So let's see. Let's change just the maximum margin of error to 6% and see what that does. So I'm going to leave my confidence level at 95% and change this to 6%. Okay, so that gives me 194.6. I would round that up to 195. So that's acceptable with the sample size that I have. Because this is less than the sample size that I actually have, so that one is going to work. So for this example, I'm going to decide based on that I'm going to use a 95% confidence level. And what I chose for my maximum margin of error, I'm not actually going to use that in my calculations for my confidence interval, but I should know when I come out with my confidence intervals, that should be the biggest possible margin of error I would get. If I come out with something bigger than that for my margin of error, then I've done something wrong. So my margin of error that I come up with should be no larger than 0.06. Okay, so that's the part of making the design choices. The next thing then in the assignment is to find the margin of error. And for this, I know this is a lot of repetition, but sometimes you kind of need this for practicing on the confidence intervals. For this, you have to do a different confidence interval for each different color of M&Ms. So I'm going to go back to my data that I had here. Now, it doesn't say in the assignment anywhere that you actually have to calculate all this stuff by hand. It does give you the formula, but you can also use Statcrunch if you want to. So I'll show you kind of both ways. I'll calculate the margin of error by hand for one of my colors, and then I'll kind of show you how to do it with Statcrunch also. So let's just calculate, let's see, let's calculate the confidence interval for the green M&Ms. Okay, so for the green M&Ms, my sample proportion is just that relative frequency that I figured out for my data collection assignment, so I already have that. My sample proportion is just the proportion of green M&Ms that were in that sample, so it's the relative frequency, so it's the 0.1261. And yours is going to be different. This was just my sample. So the sample proportion in the formulas we have is the p hat. Okay, and let's go back to the margin of error formula. This is the formula that I'm going to use. Now the nice thing about this with the design choices I made earlier is that I already figured out my z alpha over 2. So that I already have. It's what I used in the sample size formula, so it's 1.96. So my p hat, this is coming from my sample, so I've got that, and then my sample size is the n. So in my case, that was 349. So all I'm going to do is plug these things into this formula and get my calculated margin of error. So I have the 1.96 there, 0.1261 here, 1 minus 0.1261, and then divided by my sample size. One thing about this, when you're calculating this, is that sample size, the n, actually goes underneath the square root. So when I put this in my calculator, I'm going to put it in just like that, all in one step. That way I don't have to worry about how much to round. So I've got the 1.96 and then the square root. The only thing about this is that you have to be careful how many parentheses you put in there. So notice I did put parentheses around the 1 minus 0.1261, just like it was in my formula. And then I need another parentheses at the end. Okay, so that gives me 0.034. And for your margin of error in this, you should round it to 3 decimal places. Oops, which would be 0.035. I just looked at the first 3 of those and I didn't notice the next one was an 8. So this one, round it to 3 decimal places. Okay, so that gives me my calculated margin of error. So then the next thing is to actually figure out the lower and the upper limits for my confidence interval. So my lower limit is my sample proportion, which was the 0.1261 minus the margin of error. My upper limit is my sample proportion plus my margin of error. So I've got the 0.1261 minus the 0.035 and the 0.1261 plus the 0.035. Which gives me 0.0911 and 0.1611. Now these also, for the limits, we're going to round these to 3 decimal places also. So I'm going to round this to 0.091 and I'm going to round this to 0.161. Okay, so one thing about these, notice these are still in proportion in decimal form. If you want to list these as percentages, that's okay. Just move your decimal point over 2 places. Now that we're done with all those formulas, we can turn these back to percentages if we want to. Eventually, not in this assignment, but in next week's assignment, we'll be comparing these to what they had in the Mars Company letter. So in that case, since those were percentages, then we'll probably want to list them as percentages. So we could say this would be 9.1% and this would be 16.1%. Okay, so that would be for my green M&Ms. To do my other ones, I would just go back and I'd have the same Z alpha over 2, the same sample size, so the same N. The only thing that would change for the other colors would be my sample proportions. Okay, now let's look at how we would do this with Statcrunch. And this is actually not too hard. You just have to go to Stat and do Proportion Stats. We're just looking at one sample, and what we have is a summary because we already have all the numbers. We're not working off of raw data. So I would do one sample with summary. Okay, so for this, I need my number of successes and my number of observations. So number of successes, in this case, would be the number of green M&Ms I had. And here we're not dealing with a proportion, we're dealing with the actual number. So if I go back to my data over here, my actual number of green M&Ms was 44, so that's my number of successes. By number of observations, they mean the sample size, so for me that was 349. And then what I'm trying to do is a confidence interval, and this lets you put in the confidence level you chose. So it automatically puts in 0.95 since that's kind of a standard one, and that is actually what I had used for my confidence level, so I don't have to change this. If I were using a different confidence level, then I would put a different number in here. Okay, and then that's all you have to do, and it does all the work for you. So this comes out, it tells you what your sample proportion is, which is the same as what we had over here, the 0.1261. And it gives you the lower limit and the upper limit for your confidence interval. Now, and here where it says the standard error, that's actually part of our formula for the margin of error. Let me go back here and show you what part that is. So that's the part of the formula without the critical value. So this part in here, inside of the square root, this is actually your standard error. So you could kind of check yourself if you're trying to do this by hand and then check it with Statcrunch. If you just do this part of it, that should come out to be the same value they got for the standard error right here. And then to actually get your margin of error, you'd have to multiply that times your critical value. Okay, but this does come out with the same lower limit and upper limit that we found. So the 0.091 and the 0.161. So that's just a way you can do it. So again, to get there, you go to Stat, Proportion Stats, one sample with summary, then put in your number of whatever color of M&Ms you're talking about, number, not proportion. Your number of observations is the same as your sample size, and then click confidence interval, and then put in your confidence level. That's all you have to do for that. Okay, so the last thing on the assignment is to do statements for each one of the confidence intervals you find. So again, you're going to repeat this process of finding the confidence interval 6 times, once for each color. And then for each one of those, you're going to write a statement saying what the confidence interval actually was. And I gave you a standard form that you can use in the assignment. And that's basically like this. It's going to say I am, and then you put your confidence level in here. So for me, since I used 95%, I would put in 95%. Okay, and then for a confidence interval statement, we want it to be specific about what population we're talking about and what parameter we're trying to estimate. So in here, I want to put in here somewhere what variety of M&Ms I had. So I'm going to say that for plain M&Ms, the true population, and here if I'm using proportions, so if I'm using it in the decimal form, I'd say proportion. If I'm using percentages, I'd say percentage. And then I want to say what I'm talking about. I'm talking about the green M&Ms right here. So you're going to write one of these statements for each different color. Okay, so the true population percentage of green M&Ms is between, and then I'm going to put down my lower limit and my upper limit. So in my case, it was between 9.1% and 16.1%. Okay, so in the assignment, you're going to do this once, and you can copy and paste these. I know you don't want to have to type this out 6 times, but I do want to see 6 different statements. Everything in here is going to be the same except the color is going to be different for each one of your statements, and then your numbers are going to be different for each one of your statements. Okay, one more thing to notice about this. I was saying that what you chose in the beginning for your maximum margin of error isn't going to be, it shouldn't be the number that you actually come up with for your margin of error. So let's go back and look at that. Up here, I decided to choose 6% for my maximum margin of error. And I said here my margin of error should be no larger than 6% or 0.06. What I actually came out with for my margin of error was 0.035. So that was actually quite a bit smaller than my 0.06. That's not too surprising because this came out with my minimum sample size of 195. My sample size is quite a bit bigger than that. The bigger your sample size actually is, the smaller your margin of error is going to get. So if my sample size is a lot bigger than my minimum sample size that I came up with here, then my margin of error should be quite a bit smaller than what I chose for my maximum. Okay, I hope that helps you when you're trying to do this assignment. And if you do have any questions about the assignment, please feel free to ask me. Like I said, I know this gets a little bit challenging when we start talking about confidence intervals. All these formulas and everything, we haven't had to use a lot of formulas so far. And again, if you want to do this part using Statcrunch, that's fine. I just wanted you to know what all these different parts were and what the results you get in Statcrunch actually tell you. And then write out your interpretation statements this way.